Welcome to Lesson 2, Example 13. And in this problem, they're asking us to find the maximum horizontal shear stress. And as soon as you see horizontal shear stress, you know that the equation you want to be looking for is, and some people just write it as V equals V, and that's your shear over I. And I've always used T, but they use B. And the T is the thickness, or B is the thickness. We'll go ahead and not make it confusing. I'll make it B. I always learn VQ over IT. Anyways, we'll go on and you can remember or figure out what is what here. But V equals your shear. And that's when you do your shear moment diagrams, or you make your cut. That's going to be your shear. So there it is. That's what you get. You get shear. LBS. There we go. And that's shear. That's your V, your Q. And your Q is a little bit less defined. It's and I really always something you just have to remember. Nothing that really made sense to me, and they always tried to explain it, and it didn't quite set in, except I just remembered how to do it, and once you remember how to do it, you really don't need to know exactly what it's defining, but it's pretty much the stress of the top or whatever part you're talking about. Or it's similar to I, or yeah, similar to I. Anyways, what it is you take the width times the height of half of that section right there, and then it's times the whatever your moment arm is of that, the centroid of it. So the centroid of that section is right here, and that's going to be at 3 inches. So it ends up equal the width, which is 4, times the height of half, and then times 3 inches, which is the half of 6. And that equals 72 inches cubed. And read through what they say about Q, and you'll figure out, hopefully get a little bit better understanding than I'm going to give you now. I might do a video on it later to better define it. But right now, it's kind of like I haven't really defined I very well. It's just a section property. That's all I'm going to leave it as right now. I'll go in and make videos about it later, and hopefully that'll give you a better understanding. But for right now, they're pretty easy to find. So just memorize how to do it and memorize a few equations. For instance, I, and this I guess we have to figure out I as well, equals BH cubed over 12 plus AD squared. And you'll see this AD squared, but when we're talking about symmetrical beams, really simple symmetrical sections, D will end up going to 0 because we talk about, and hopefully you can go through some of the old, I tried to explain that in some of my old videos, but if you do the entire beam at once, the centroid is on the neutral axis, or the centroid is on halfway, so this will end up going to 0, in other words. So you end up getting B, it's just 4 inches, your base, times your height, which is 12 inches, and that's cubed over 12. Let's put that in a calculator. And we get 576. And 99% of the time, your I is going to be in inches to the fourth. Sometimes I guess it could be in foot to the fourth, but that's a pretty darn stinking huge section. And I always just make it, because most of the time it's going to be in inches to the fourth, so you kind of get a feel for how big the beam's going to be, and it's kind of a dummy check putting it in inches to the fourth and say, well, that sounds about right. And for this beam, small beam, 576 seems about right, and I'll go ahead and check that as well, and it is. I equals 576. Then let's put that up here, 576 inches to the fourth, and then we want to do B, which is 4. It's this dimension right here. And let's go ahead and do the math on this. 7,000 times 72 divided by 576 divided by 4 is 218.75. And this is our horizontal shear stress, 576. We check that answer, and it does line up. No, that's not the shear stress, that's the I. Sorry. right here, 218.75, and I didn't even put the units on there. That's I under V equals 576. Shear stress equals 218.75, and check that, and it is correct, and it's PSI. And let's go ahead and check the units. We have pounds. I'm just going to write the units over here real quick in green. Well, we're going to have pounds on top times inches cubed. And then we have on the bottom we have inches to the fourth times inches. So altogether we have inches to the fifth on the bottom, inches to the third. That means it's going to be pounds over inches squared. In other words, you have inches to the fifth, 5 minus 3, you're left with 2 inches squared on the bottoms, and that cancels all the way out. So you have pounds per square inch. And then we match that up and checked it, and it is good.